In the previous section, we focused on process of implementing spatial information science to formulate a space-related problem and its justified spatial solution. Their theoretical and technical knowledge was essential to provide a foundation helping in executing the spatial information science-based projects. In that discussion, we examined framework for the development of some spatial information applications. There, the emphasis was on the practical aspect of designing and managing a spatial information application. The design techniques was considered to identify the nature and scope of a problem, defining the system to build, quantify the amount and type of data required, and indicated the data models and the kind of analysis which is required. So here in this section, we would emphasize as there are several critical development stages that support a successful implementation of any project. As you can see in this diagram, understanding the importance of each stage is the key objective for success, leading to more effective enterprising implementations. The figure shows a series of typical system development stages for building and managing successful enterprise in spatial information operations. So here, if you look into the different stages, I would say the first is the requirement phase, where user needs to establish a foundation for completing the design. This user needs are important. Another can be user location and prepare a foundation for system design. Second is the design phase. So the first is the requirement phase. The second is the design phase. Here, infrastructure requirements needs to be identified. Consideration for network communication capacity, hardware and software requirements needs to be identified, and software requirements and data execution needs to be identified. This is the design phase. The third is the construction phase, where system development based on the design, budget, timeline. Another can be the data acquisition and database design initiation. Another can be application design and development. There can be also prototype testing plans and validation of the project also. This would be the third phase of project design. The fourth is the implementation phase, where initial development and operational testing is to be done. Final system delivery, user training and workflow migration, etc. they can be incorporated here. The system maintenance operations are also looked into it. The fifth is the capacity planning. Capacity planning tools, which is commonly known as CPT, developed as a framework to promote successful spatial information system design and implementation. That would be the ultimate objective of the project design. The CPT, that is capacity planning tools, tasks include reviewing business needs, what is the requirement, establishing performance targets, identifying user locations, reviewing network suitability, selecting product and completing the system design analysis. All this will come into this capacity planning tools. Additional tools are provided to validate system performance during the design, construction and implementation phase. So all in all, I would say that this is how the cycle of project design implementing, which we may take as the strategy for implementing any project in spatial information. There can be many problems also in implementation, so that is also being needs to be highlighted. So there will always be problems for spatial information science design and development. But if proper planning is not done for developing the project, three of the most common problems which can come and which may affect the project, if I can highlight them. First can be the data in the wrong format for spatial information operation. That is a big challenge. So data needs to be in appropriate format. Second can be a lack of spatial information knowledge. So that will result into imposing technical and conceptual constraints on the project. The third would be the user of spatial information frequently changing their objectives. So if they are not clear as to what they want to do with spatial information, then again there would be a implementational challenge, implementational hazard. In many spatial information science projects, the data required might be not easily accessible, or if they are available, it may not be in compatible format with the softwares or analysis is requiring. This need to be overcome, and this can be overcome simply by converting the data into the desired format. But we have discussed at length that the conversion may result into many kinds of errors. The errors may creep in as data are changed from one format to another. Alternately, the conceptual data model could be revisited to assess the importance of the data and evaluate if there can be any alternate data options. It is inevitable. At some point, that application will be limited by users' technical or conceptual knowledge about which spatial data model, data structure, or analytical operation is most appropriate for the task required. Much can be learned from other applications and other users also. That helps a lot. Then another important aspect, if I can highlight, it is the dynamic nature of spatial information design process. It is as such that the information needs of users are often in a constant state of flux. By the time a spatial information data model is implemented, the need of the users and the scope of the problem may have changed. It might have moved away from the original defined by the rich picture, because we are dealing with dynamic phenomena. So the change is the reality. So we need to understand and we need to incorporate and inculcate into our idea the objectives. This is a major issue in the development of spatial information application. The solution is to gain frequent feedback from the individuals who will be the end user or to whom we are performing this exercise. Another can be the project evaluation, the part of assessing the project. It is an essential element of project management, project evaluation. After a spatial information project is completed, you might have encountered some problems, and you may further have certain problems which would come after the completion of the project. It is extremely necessary that the output produced by the project system is usable, valid, and meets the goals set at the beginning of the project. So, validation of results are often difficult to achieve, particularly if results are in the form of predictions. In many cases, this may result in adjustments in rich picture. And the spatial information data model, this may result further into adjusting the results, because we are dealing with ground realities. We are dealing with different relationships, and all of them, they are dynamic. So we need to make some kind of adjustment also. So this feedback process can be expensive, and adoption of the prototyping approach is picked instead of prototyping prevent a system from being inappropriate, and frequent testing and evaluation requires to be done. So there are 3 tests that can be used to check whether a spatial information application meets the goal set for it at the start of the design process. First can be all involved in design and development of spatial information science can be asked if they are using the application for the purpose for which it was designed. If they are not, or have even reverted to using the old methods, it is a sure sign that something has gone wrong somewhere. The goals originally used to guide them in helping to identify the scope of the problem that may have changed as time and work priorities have altered. Alternatively, users may find the application difficult to use or without a key feature. In such cases, further training and adaptation to softwares or the programs or the operations which we are employing in the project needs to be done. The second can be the spatial information output that can be checked against the reality. For example, this type of test would be appropriate for the flood prediction model, for example, as the location of flood could be predicted before the start of a season and then compared against actual flood at the time of the season, and how much is the deviation. That will give an idea. The third can be the adaptations and changes that had to be made when moving from the rich picture through the spatial information data model. And in spatial information science implementation, that needs to be evaluated, whether these were due to knowledge deficiencies or the problem of definition or to improper system adaptations. If the system adaptations have dominated the development of the application, then it may be that a technical solution needs to be provided that has little resemblance to the reality of the initial problem which we might have conceived. So these are some important aspects of execution, effective execution of spatial information science project which we may initiate.